All right, what we're going to start with is solving trigonometric equations. Now, the idea, we're going to have to keep these videos about 12 minutes in length. Otherwise, for some reason, YouTube won't accept it because the files are too large. So, unfortunately, we're just going to have to do several videos to get through all the lectures. So I'll try to break them at reasonable points. All right, solving trigonometric equations is a topic that we get to right after we talked about the inverse trigonometric functions. So, for example, in the last section when I said, okay, what is sine inverse of the square root of 3 over 2? Well, this was interpreted as, well, we would say equal something. We would interpret this as then sine of x has to equal the square root of 3 over 2. And we said, well, that's true if x is equal to, we could say 60 degrees, or we could say pi thirds. Remember us talking about memorizing these values. These are very important ones, and we keep coming back to the same ones time and time again. It's important that we become familiar with these to the point where we'll just look at something like this and know immediately that, sine of x equals the square root of 3 over 2, well, that's 60 degrees, or that's pi thirds. We'll just start associating those numbers and these ratios. So that's going to be an important thing. But this guy right here, this statement, that sine of x equals the square root of 3 over 2, that's going to be the start of our trigonometric equation concept. We're going to be solving equations that start off here, not here. So the idea is, yes, we're going to be talking inverse, and what we solve here is going to be given a specific name. We're going to be calling these eventually the principal values. Principal values, in this case, refer to what you get when you actually punch this in on your calculator. When you do the sine inverse of the square root of 3 over 2, you're doing the functional inverse of sine, in which case you can only get one answer here, and you get 60, or, like I said, pi thirds. However, if we start off at an equation like this would be called a trigonometric equation. We can find other values where this would be true. So for example, yeah, the sine of 60 is the square root of 3 over 2, but so is the sine of 120 degrees. And anything coterminal with a 60 or 120. And how I know that? Because if you draw a 120 degree angle, not only is it a 60 degree reference, but you're in quadrant 2 where sine is still positive. So anything that's a 60 or 120 or any reference angle or any angle that has a reference of a 60 or 120 will also be considered a solution to this equation. Right? So before we get too far ahead of ourselves, let's quickly define, or more or less compare and contrast the difference between, let's try a different color here, an identity that we're very familiar with and a trigonometric equation. Right? When we talk about an identity, we're referring to something like sine squared x plus cosine squared x equals 1. Or tangent of x is equal to sine of x over cosine of x. Now, granted, these are equations, no doubt about it, but these equations are true for all values of the variable. Assuming that they're in the domain of the function, we have to be a little bit careful with tangent, of course, but the idea is this is true for all values of the variable. Now, if you compare that to a trig equation, now it goes back to what our concept of equations are. Like, for example, we might say that 2 sine of x plus 1 equals 0. That's a trig equation. Or tangent of x minus the cosine of x equals 1. Just to give an example of two things. These are not true for all values of the variable. There are values, maybe several, maybe infinitely many, but not everything works in these equations. That's the idea. So when we talked about identities and we would verify identities, we would have to treat these as expressions. So when you were asked to verify an identity, you had to work with the left side, simplify it, work with the right side, simplify it, and try to meet in the middle to prove that the statements were true. Well, here, in an equation, we're not saying this is true. We're saying it's true for certain values of the variable, not for every value of the variable. Right? So the idea here is we're trying to solve for x. Or theta, or whatever the particular variable is. Which means the rules that we use for verifying identities, they're kind of not something we have to heed to anymore, because with an identity, you had to work with both sides. You could not treat it like an equation. With an equation, you are definitely going to treat it like an equation. So that means you might want to add or subtract stuff to both sides, or divide things to both sides, cross multiply. All those sort of things are now in play. All the things that you did when solving an equation, you can do with a trig equation. So there are certain things we'll have to be careful of, but the bottom line is now we're free to solve these like normal equations. All right. Now, in doing that, we'll start off with some simple ones, and we'll show you the concept graphically, what this means when we're actually solving a trig equation, and then algebraically, of course. All right. So let's take an example. Say I had this equation. I want you to solve sine of x equals 1/2. Right? That's pretty simple, most basic, one of the more basic trigonometric equations that you're going to run into. The idea here is, when does sine of x equal 1/2? Now, graphically speaking, here's the idea. If I graph out what sine looks like, and I do, I suppose, 2 periods or whatever, just go 2 pi, pi, and I'll show you graphically what's actually happening when we're solving these equations. Now, you'll be thankful that we're not going to solve these by graphing. A graphing method is not such a good idea when you have to do this by hand. Right, so here's 1, here's -1. All right, graphing sine, start at the origin, climbs, and back the other way here. All right, so let me draw this. And of course, this wave goes on forever. It's just, we graph 2 full periods and a little bit extra. The idea is it is an infinite wave. It goes on in both directions. Now, this is what we would call sine of x. That's the graph, sine of x, or y equals sine of x, I guess to be more precise. Now, we want to graph the function y equals 1/2, which is nothing more than a horizontal line through 1/2. So if you graph a horizontal line that passes through 1/2 on the y-axis, you can see where it hits the graph of sine of x. Hits it at several points. So from -2 pi to 2 pi, it's already hitting at 4 distinct locations. These points right here, those are solutions. Each one of them is a solution. Now don't say, oh, I guess there's 4 solutions to this. Well, there's 4 solutions to this equation if you are solving under the restriction -2 pi is less than or equal to x, which is less than or equal to 2 pi. Solving under those restrictions, yeah, there's going to be 4 solutions. Because this line, y equals 1/2, I guess I should have labeled it, y equals 1/2, hits the sine graph at 4 distinct points. Now, a lot of times we don't do -2 pi to +2 pi. A lot of times we'll just go 0 to 2 pi. If I do that, then all of a sudden, from 0 to 2 pi, well, there's only 2 solutions. Right? And we can restrict this even further. We could say, well, we only want to solve from 0 to pi halves. Well, if we go 0 to pi halves, then you're only getting one solution. Now, what this solution is, we'll see in a minute, but the idea is we're only getting one solution. Now, what we do a lot of times is we will solve for what are called principal values. So they might say solve from negative 2 pi to 2 pi, or 0 to 2 pi, or 0 to pi halves. Or they may say solve for principal values. Well, principal values, in this case, fall under the, I guess, distinction of using the inverse function to solve this. So to solve this equation in the most specific sense, let's take this sine of x equals 1/2. We have to inverse sine both sides. That is, sine inverse of the sine of x equals sine inverse of 1/2. Sine inverse of sine, or a function with its inverse composed, will cancel each other out. I mean, we do have to be careful on certain ones. Watch that. But in this case, just say x equals, and then the sine inverse of 1/2 turns out to be, I guess I'll start off with 30 degrees, so you're familiar. Or since we're talking radians, we're looking at pi 6. This is called your principal value. It's the one the calculator operates on when it does a functional inverse. So as far as solutions go, we can't just say, hey, solve this. Because if you solve a general trigonometric equation, since they are periodic, there's going to be infinitely many solutions because this wave keeps going on, and it's going to, whoops, good. It's going to keep intersecting this horizontal line at, infinitely many locations, so we kind of have to restrict where we're solving. So generally the directions don't just say solve, they'll say solve with this restriction, or this one, or this one. Or maybe they'll say principal values, or some other variation. But that's at least the start, right? We'll talk more about this on the next video.